Almost finished with math for the week. Today we're talking about squares and square roots. When I said that, Wayne goes, "We've got lots of roots out in the garden." Dad humor. Okay, first I'm going to just read directly from your sheet. So you're on page 265 in the yellow box. Area of a square is the product of the side by itself. Remember, product means the answer when you multiply. So the side times the side, whatever that number is. If it's 8, 8 times 8. If it's 64, 64 times 64. If it's 2015, it's 2015 times 2015. It's not the side times 2. It is the side by whatever the side is. Same number twice. Multiply it. 3 times 3 equals 9, or 3 squared equals 9. A small little bit written to the right and above a number is called an exponent. The exponent 2 means to multiply the number, which is called the base, by itself. So we've got 4 times 4 here. 4 squared is another way to write that. This 4 is called the base. This 2 is the exponent. This little exponent says take the base and make the number 2 times. So 4 times 4. Remember again, this is not addition. It's not 4 plus 4. It's not 4 times 2. It's 4 times 4. Exponents can get bigger, but it always means multiply that number the number of times of this. So 4 times 4. Okay, if this exponent was a 5, we'd say 4 times 4 times 4 times 4 times 4. That wouldn't be called squares though. But so whatever that number is, that's how many times you write this number to multiply it. All right, so let's look at a few of those. 3 squared. If I were going to multiply this, or say it as a multiplication, instead of 3 squared, I would say 3 times 3. See? 3, 3. So what's 3 squared? What's 3 times 3? 9. I've got 8. 8 times 8. What is 8 times 8, or 8 squared? 64. 10 squared is 10 times 10. 10 squared is, well, what's 10 times 10? 100. Very good. Now let's look at the next part of the book. The process is the opposite of squaring. So we just squared. We just times by time. We just did number times number. The opposite of that is called the square root. Finding the square root. The symbol is used to show that a square root is to be found. What does that symbol look an awful lot like? Looks an awful lot like division, doesn't it? But look at the difference. This is a really sharp, it's like a check mark almost, versus the little swoopy house. Or sometimes when we're in a hurry, we don't even write the little swoopy, do we? We just do this. Just a straight line up and down. But here's the big difference. See how this 16 is all by itself? In a division problem, you would have your number inside the house, but then you would have your number to divide it by outside the house. Whether you wrote it as a straight line or whether you did it as a little hooky do. This doesn't have that. It only has one number because what the square root, well, let me go ahead and finish. 25, that, do we do 25 is read the square root of 25. Okay. So this is read the square root of 16. And what this is saying to you is, what number do you multiply by itself to get to 16? Well, 2 times 2 isn't 16. 3 times 3 isn't 16. 4 times 4, that's 16. So the square root of 16 equals 4. Okay. Now you notice I didn't write the answer on the line because this isn't a division. This is a square root. Let's do a few of those together. I've got the square root of 25. What times itself equals 25? 5. I've got the square root of 16. We just did that one. 4. Square root of 36. What times itself equals 36? 6. And what times itself equals 81? 9. So it's your multiplication doubles. You have those memorized, square root is going to be easy peasy. But if you get to one and you just kind of forget, let's say you forgot that 6 times 6 was 36. This is easy enough to do with these small numbers. Go with, okay, I know 5 times 5 is 25, so what is 6 times 6, the next one? Oh yeah, that one's 36. But if I'd forgotten, I would just go, 1 times 1 is 1, 2 times 2 is 2, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. Oh, ding, 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 I found a winner. That's all there is to this. They're not giving you units of measurement because in this situation, you're not finding a unit of measurement. You're just finding the square root of a number. Not all numbers have a square root because not all numbers, not all numbers have a square root that is just a whole number with no decimals. Let me put it that way. Because mathematically, I'm sure some brain can find a square root to basically anything, but some numbers it's just going to continue forever, like 0.7777777. For our purposes, though, what we're doing, just the straight whole numbers, not every number is going to have a square root. I mean, think about it. Is there something that if you multiply it by itself could be 7? What about 3? So just remember, you're not going to be able to find a square root for every single number of our normal number charts. But for your purposes, you're just going to be thinking about when you're doubling our regular numbers. 2 times 2, 3 times 3, 4 times 4. Just said I was going to stop erasing yesterday. Well, not really yesterday. Yesterday for you. Just a few minutes ago for me. That's why I'm still in my hoodie. Y'all, it's chilly outside today with all this rain. This part can seem hard because it's got new words that you've never seen before. And it's got a new symbol that you've never seen before. But it's really very easy as long as you remember that that is not division and the exponent is not telling you to multiply by 2. You're multiplying by itself. You're figuring out which number, if it's times by itself, makes that new number. You've got this. And if you don't, if you get stuck, shoot me a text and I'll give you a reply. Bye.